Hello everyone, so in this video, let us talk about another problem from LeetCode weekly contest 381. The problem name is count the number of houses at a certain distance 1. So you are given three positive integers n, x, and y, as you can see here in the input, n, x, and y. Now in a city, there exist houses numbered from 1 till n, and they're connected by n streets. Okay, they have n streets down there. There is a street connecting a house I with a house I plus 1. So there is always a street that is connecting I and I plus 1, and there's an additional street that connects X and Y house. Okay, so which means that you have, let's say, five houses. So the five houses will be like one, two, three, four, five. So they will be connected like this. But there's also one more street that is given to you as an X and Y. So let's say there's a number of house number is one, two, three, four, five. So it will, like, this X and Y can be anything. It can be like this two and four is actually also connected, or maybe three and five is also connected, or maybe one or four. So any one extra street will be there that is connecting X and Y. Okay. Now for every k is from 1 till n, you need to find out the number of pair of houses, house 1 and house 2, such that the minimum number of streets that need to be traveled between house 2 from house 1 is k. Now, it actually means that you have to find out the number of pair of houses you have to calculate out for every k. K means that k is a distance. So let's say the overall problem boils down to that how many house pairs are there which has a distance between them is equal to 1. Their minimum distance between them is equal to 1. The minimum distance is equal to 2. Minimum distance is equal to 3, and so on. So till from 1 till n. So you have to count out the number of pair of houses in this particular map that you are given to. You have to find out the houses, the minimum distance between two houses, pair of houses that has the distance between them equal to 1. Then how distance equal to 2, and so on. So all of them you have to find out. So as you can see in the output, in this particular example, this is the map actually. 1, 2, 3 is connected like this, and there's also a street from 1 till 3 as well. Now you have to find out all the pair of houses that has 1 as a distance, minimum distance 1, minimum distance 2, and minimum distance 3. So as you can see that there is no houses which has a minimum distance 3. All the houses can be reached, all the pair of houses can be reached in a distance of 1 only. Okay. Now that's the thing. You can see here, if I just scroll down here as well, you can see some examples as well. Now, how you can solve it out? You can see that the constraints of this is pretty much small, like very small, like 100 only. So the only thing that comes to my mind when I see shortest distance between two positions is BFS. BFS can be used to find out the shortest distance between 2 points in a graph, you can say. So this is also a graph. Okay, you can make an adjacency list of all these particular houses. It has to be made once because all the houses 1, 2, 2, 2, 2, and 3, all of them connected by a bidirectional street, you can say, or edge. And you can make a adjacency list, and there's also a bidirectional edge that is from x to y and y to x, you can say that. And you can make an adjacency list out of it. Then you can do BFS for every house. Let's say from house 1, what is the minimum distance to reach 2, 3, 4, 5, and so on. Okay, so you will find out the minimum distance to reach from a particular house to all the houses. Okay, so that you are making every pair possible from 1 to all the houses, 2 to all the houses, 3 to all the houses. And whatever the minimum distance you find out using BFS, you will keep on adding in some array you can make that will store all the distances between these two houses. Okay, and then you can just print out the answer. So nothing much complicated here itself. Like, you just have to find out, to use BFS to find out the minimum distance between two positions and just print it out. Okay, so I'll directly move on to the code part now. If you still have any doubts, you can mention it in the comment box. I will be happy to explain to you. So what we have done is that the thing is one index, as you can see here. So it's better to move it 0th index. So I will subtract out from x and y 1, 1. Then this is the answer vector that will store all the distances for every k. Okay, so from some k is from 1 till n, as you can see. So for I make a array from till n. So for every position from 0 till 1, n, I have to find out what is the minimum distances we have. So for every house, like for our house 1 till all the other houses, 2 to all the other houses, what is their minimum distance? So this is the BFS starting from the ith house, because the houses are also numbered 1. So I'll do it from I minus 1. So from this house to all the houses, there's also an additional x to y mapping. And then you have to find out and add all those, you can say, minimum distances in the answer vector and just print out answer. So what is this BFS function doing? Simple BFS, you have to make If you have not known about BFS, go check out my other videos, or you can read online on different websites. First, what is BFS, and then you can come down to this. So we have to use a queue for this. You have to push out whatever element I am on. You have to also make a visited vector, so that because it is a bidirectional graph, so we have to also, and it has a loop as well, you can see. So we have to also ensure that we cannot go in a loop. So we have to make a visited vector, and we will just keep on doing a while loop till all the nodes in this particular map are covered. Okay, then to find out distance, we'll first find out whatever is the element I am on, and we'll keep on incrementing distance. So whatever is the, you can say, nodes from where I start. So let's say I start from 1. So all the nodes which is just directly adjacent to them are 1 distance. All the other nodes which is like 2 distance away from a 2 distance, and so on, because I have to find out minimum distance from here. Okay. So what we have done is we have to find out the distance. So distance is whatever distance I have covered till now plus 1. Okay. And then we'll iterate over all the other nodes, because it's a bidirectional. I have to move from I plus, like whatever node I am, +1, -1, all the current node X and Y, all of that. It's a simple BFS thing. And we have to check that it should not be visited. If it is not visited, we'll push that inside the queue and make it as marked as visited because we have visited it. And this will keep on incremented distance. And whenever I find a distance of a particular pair, I'll update it inside, you can say, the answer vector, that what is the distance between two every pair that I'm actually forming out. And in the end, we have all these values because I'm passing it by, you can say, reference. Not sorry, passing it by value. Not value, sorry, passing it by reference only. I'm my bad. So it's by passing it by reference only, so that we will keep on using the same array and keep on updating for all the particular houses pairs. And in the end, we'll just print it out. Okay, there's a complete logical code part for this particular problem. If you still have it out, you can mention in the comment box. All this particular code is available here. You can pause out this video and try to code it out for yourself as well. And that's it. In the end, I will see you in the next one. Keep coding and bye.